This is a really critical question that we refer to as splitting an equation. There's a little bit of background here, and the background is that for an intersection, the one-liner, the idea of what you do in that situation is you get both equations. If I'm being asked for the intersection of two functions, I'm going to get both of the equations in the y equals format, and then I'm going to set them equal. I'm going to get both of my equations in the y equals format, and I'm going to set them equal. So as an example, let's say we had y equals 5x squared and 2x plus 3y equals 10. And if I'm asked for the intersection, then I'm going to say, okay, well, I need to get this into y equals. So 3y is negative 2x plus 10 divided by 3. Y is negative 2 over 3x plus 10 over 3. And then the next thing you do is you set them equal. So 5x squared equals negative 2 over 3x plus 10 over 3. And from there, it's just a matter of solving for x. So that's how intersections work. So now the flip side of that is if I see something that's already set equal, I can ask myself, was that an intersection? And if it is, then that means I can kind of go back to seeing them as two separate functions. And that's what we're going to do here. We're going to take the original equation they gave us and imagine, well, what if we had y equals negative 3x plus 21px? And what if we had y equals 84? And what if what we were looking at in the beginning was an intersection? So for our intersection rule, get both equations in the y equals format and set them equal, we're going to go ahead and say, so the opposite must be true. The converse, I guess you can call it, which is the idea that if I see two things equal, I can assume, or I can wonder at least, if maybe this is an intersection that already took place. And if we think of it this way, this is something that can be moved into y equals mx plus b format. So we can factor out x, and that would leave us with negative 3 plus 21p. And in y equals mx plus b format, we have y equals negative 3 plus 21p, x plus 0. So we have an expression for the slope, which I'm going to make a little neater, and the y-intercept, which is 0. Now, this line right here is a horizontal line. And whenever you have a line in the format of x equals something or y equals something, you can think of it as the name. Here you have y equals 84. So you can think of this as a collection of all the points with a y value of 84. And all the points with a y value of 84 would be a horizontal line where all the points on this line have a y value of 84. So 0, 84, 184, 284, 384. But what's the slope of a horizontal line? It's 0 because it's not tilted at all. It has no slope. It's as flat as the floor. So if we're thinking we have this equation of a line and we have this equation of a horizontal line, and there's no solution. Now, what does no solution mean for two lines? It means that our two lines never hit each other at all. So our other line has a y-intercept of 0. So we know it passes right over the x-axis, and we know it never hits the red line because they're parallel. That's the only way two lines can never hit. So if you have two lines and they never hit, that must mean that the slopes are equal. So the idea of splitting an equation in this really tough situation is the idea of saying that this slope of this line that we're being given here must equal the slope of the horizontal line. Now that horizontal line, y equals 84, if we decided to put that in y equals mx plus b form, that would be y equals 0x plus 84, as weird as it looks. But seeing it that way reminds us that the slope is 0. Like I said, if the two lines never intersect, it means the slopes are equal. So all we have to do here is say -3 plus 21p equals 0. Add 3 to both sides, divide by 21, and that simplifies to 1/7, and that's our answer here. So in this question, there's a lot of theory. There's a lot of thought that had to go into why we're doing what we're doing, but there's actually very little math. And this is a question that comes up repeatedly. You want to be able to recognize it. You want to be able to look and see if I have two linear situations equal to each other and there's no solution, that means the slopes are equal if I think of them as two separate functions. So there's a lot of sort of theoretical work being done here, but very little math. We just set them up as two separate things. We identified the two slopes, we set them equal, and that gives us answer choice B.